have the indefinite integral of 1 minus the cotangent squared of x dx. And again, I've erased the formulas, riding without the training wheels, I guess. So, we look at this and we say, oh, well, what's the, we could break this up and we could say, well, what's the integral of 1 with respect to x? Well, it's x. But then we get to negative cotangent squared of x, and, excuse me, we don't necessarily know the function whose derivative is the cotangent squared of x. But again, as I mentioned in the last example, anytime I see one of the trigonometric functions squared, I'm asked to antidifferentiate, and I don't know it's not the cosecant squared or the secant squared, then I think of the Pythagorean identities and how I can manipulate them, and these are so great. So I have the cotangent squared, so I think of the Pythagorean identity 1 plus the cotangent squared of theta equals the cosecant squared of theta, or an argument. In this case, it's going to be x. So I'm just going to and so I want to replace the cotangent squared, so I'll just make this identity. I'll make got the crayon. So here's my crayon. So this says, if I just solve for the, why did I write cosine? Don't know. Sorry about that, guys. So if I solve for the cotangent squared of theta, I get the cosecant squared of theta minus 1. So I can go over here and I can replace the cotangent squared of theta, and I'm just going to leave it all inside this integral as minus, and I'm going to draw myself some parentheses. Cotangent squared of theta squared of x is equal to the cosecant squared of x minus 1, and that's going to be with respect to x. Now I'm going to distribute that negative sign, so I'm going to get 1 minus the cosecant squared of x. Negative times a negative is a positive 1 dx. Now I'm just going to add that 1 and that 1 together, and I'm going to get the indefinite integral of 2 minus the cosecant squared of x dx. Now I'm ready to integrate. The function whose derivative is 2 with respect to x is 2x. The functions whose derivative is the negative, I'm just going to look at it like that, as the negative cosecant squared of x. How much easier can you get? That would be the positive cotangent of x. And then don't forget your plus c. That's it. I'm trying to think, is there another way you might want to do that? I guess you could add 1 and subtract 1. Would you get the same thing though? I don't know if you're really wanting to do that. You could add 1 and subtract 1 from this expression, and then put in your cosecant squared of x. You would still end up with the same thing. I don't know that that's any better. I don't know, but I'll do it anyway. Why not? This is this is an alternative way to do it, I guess, and this sometimes helps. So if this is more for other more advanced integration, but it's kind of a chance to kind of introduce you to it, so I'm going to go ahead and do it. This is just an alternative way to look at this. So I have 1 minus, and I'm going to leave some big parentheses here. And, or am I? Yeah, I am. So I have 1 minus, and I have this cotangent squared of x. And I want this identity right here, so I can put a cosecant squared of x in there, because I know the function whose derivative is that. So I'm going to add 1 so that I have this identity, but it just can't go around adding 1 into things. So, but if I add 1 and subtract 1 simultaneously, well, that's basically like just adding 0. So I haven't changed anything. So then what I can do is I can distribute, well, I don't want to distribute that negative sign. Well, maybe I do. I'm going to distribute this negative, but only to this negative 1 right here. and bring it out. So I'll have 1 plus 1 is 2, and then I'll have minus the cotangent squared of x plus 1 dx, and I need another parentheses there. Ooh, that didn't look too good. But anyway, now I have cotangent squared of x plus 1, so I can use this identity as is and just put in the cosecant squared of x. So I have 2 minus the cosecant squared of x dx. And notice I'm going to get the same thing. The integral of 2 with respect to x is 2x. The integral of negative cosecant squared of x is the positive cotangent of x plus c. I don't know. I kind of almost hesitated to even show you this, but anyway, there it is. And some people might actually show you that way. I kind of liked it this way. I think it's a little bit more straightforward, but kind of traditionally, you do actually add and subtract stuff that you want. I kind of like it because it's like, you know, it doesn't look like I want it to, and so I'm going to make it look like I want it to. Anyway, that's it.